Here we're going to go through the solution to the CAPE Integrated Math past papers. I'll be doing section C, and this is the 2016 paper. Section C, Calculus. So, first question says, let f of x be defined by the function you see here. Part 1 wants us to evaluate limit as x approaches 1 from the right. Since this is the right limit, we're looking at the values that are greater than 1. So we'll go to our function and see which domain we'll use for when the values of x are greater than 1. And it was this top one, because this is saying x is greater than 1, so this is the domain we will use. So we will simply plug our input value, which is 1, in place of the x, giving us 1 over 2 times 1, which is 2, minus 1. So simplified, this is 1 over 1, or 1. So the right limit of our function is, as x approaches 1, is equal to 1. Now part 2 says, determine whether the function f of x is continuous at x equal 1. Now for a function to be continuous at an input value, there are certain things that must be met. The limit must exist at that value, and the function must also be defined at that value. And the answers that you get for each of those must be the same. Now, what we've done in part 1 is found the right limit. So we now need to find the left limit and see if they are the same. To find the left limit, we will go to the domain where x is less than 1, which is 4x minus 3. Now when we plug 1 into this domain, we also get 1, because 4 times 1 is 4, minus 3 is 1. So here we see that the right and left limit are the same, so the limit does exist and it's equal to 1. Now we have to also check if the function is defined at x equal 1. Now we will now go to the function once more and see which domain we will use when x is equal to 1. Now this is saying x is less than or equal to 1, so we will plug 1 once more into this domain, which we know is still 1. So therefore, in this last line, it simply says that our function is continuous at x equal 1 because the value for f of 1 is the same as the value as the limit approaches 1 of our function. They are both equal to 1, so yes, the function is continuous at that value. In this question it says, given that f of x equals x cubed ln 2x, find f prime x, which is the first derivative. Now here we have two functions, x cubed and ln 2x being multiplied, so we will use the product rule. Here I have the formula for the product rule, u dv dx plus v du dx. Now u is our first function and v is the second function. So we'll plug u, which is x cubed. dv dx means we are going to differentiate v, and the derivative of ln 2x is 1 over x, plus sign v, which is ln 2x, and du dx means we differentiate the u function, which will give us 3x squared. Now we can simplify this x cubed times 1 over x to give us x squared, because x into itself is 1 and into the cube we're left with a 2. So this is our answer for our derivative, x squared plus, oh, that's not what I did. What I did was factored out what's common. So an x squared was factored out on this side as well as here. When it's factored out from here, we're left with 1. And when it's done from here, we're left with 3 times ln 2x. So this is our answer for our derivative, x squared, open bracket, 1 plus 3 ln 2x. In this next question, it's asking to determine the derivative of e to the 2x plus cos 3x. Now, we will simply differentiate each function separately. If we differentiate e to the 2x, if you recall, e to the ax, derivative of e to the ax will give us ae to the ax. So this will give us 2e to the 2x. And if we differentiate cos 3x, if you recall, if we differentiate cos ax, we will get negative a sine ax. So that's why for cos 3x, we get a negative 3 sine 3x. This next question says, the population count over time t in days of a certain type of insect can be modeled by the function p of t equals, as you see there. It wants us to find the second derivative, and that means we're going to differentiate our function twice. Now when we differentiate this constant, we're left with a 0. Negative 5t will leave us with a negative 5. Here, 2 times 0.77 is 1.54. Write back our t. Subtract 1 from the power, we're left with 1. And here, 3 times 0.01, or negative 0.01, is a negative 0.03. Write back our variable and subtract 1 from the power to get 2. So in this line is our first derivative. Now we will differentiate this function once more and get our second derivative, p prime prime t. So this negative 5 differentiated will be 0. Here, 1.54t differentiated will give us 1.54. And here, 2 times negative 0.03 is a negative 0.06. We write back the t, and our subtract from the power, 1 from the power, we're left with 1. So we have here our second derivative. Now, the next part says, given that the function p of t has a stationary point when t equals 48, show that the stationary point is a maximum. Now, a stationary point can be either a maximum or a minimum. It will be a maximum if the second derivative is less than 0 or is a negative value. So what we will do is go back to the second derivative that we found and plug the value of t as 48. So we're going to plug a 48 in this position and see if we do get a value that's less than 0. Now, 48 times 0.6 is negative 0.228. And if you add a 1.4 to that, we do in fact get a negative value. In this case, it's negative 1.34. So like I was saying before, since the second derivative, the value we get is less than 0, it is in fact a maximum. Now the third question says, find the population count when t equals 48 days. The question started and said that the population count can be modeled by this equation. So we will simply plug t equals 48 wherever the t is. We do that, we plug a t next to the negative 5 square. Oh, by the way, t was 48 if you recall. So we plug 48 in place of the t wherever it was. And when you do that and work it out correctly, you should get 635.16, and since it's asking for population count, we can round it off to an whole number of 635. So it's simply saying that the number of insects on day 48 is 635. Next question says, a spherical balloon is being inflated. The radius r of the balloon is increasing at a rate of 0.2 centimeter per second. Obtain an expression for dv dt. Now this 0.2 centimeter per second will be our dr dt because it says the radius is increasing at a rate of 0.2. So here we have dr dt is 0.2 centimeter per second. Now for us, to find dv/dt, we need to multiply our dr/dt by a dv/dr, simply because by normal multiplication, these values will cancel and leave us with the dv/dt that we need. So this is the formula or the expression that we will use to find dv/dt. Next part says, find the rate of increase of the volume of the balloon. Now there's an error here. It should read dv/dt at the instant when r is equal to 5. Now, from the formula we devised, we need to multiply our dr/dt, which was 0.2, by dv/dr. Now this dv/dr is obtained from differentiating the volume formula. Since it's the volume of the sphere was given, the formula was given as 4/3 pi r cubed. So when that formula is differentiated, 3 times 4/3 is 4. Write back our pi and subtract 1 from the power, we get 2. So that's how this dv/dr works out to 4 pi r squared. So it will get multiplied with the 0.2 as you see here. So 0.2 times 4 is 0.8 pi, and we write back our pi r squared. Since it's asking for the rate at the instant when the radius is 5, we will simply plug 5 in place of the r, making our answer 5 squared 25, and 25 times 0.8 is 20. So our answer is now 20 pi centimeter cube per second. Now we're integrating. For this first question, we have 4x plus 7 raised to the 6. Now this is this we're going to integrate using the linear factor method, because here we have a linear function raised to a power. So we'll add 1 to that power to get 7 and divide by that 7. But first we need to multiply it by the coefficient of x, in this case is 4. So 4 times 7 is 28. So we can write our answer as either 4x plus 7 all raised to the power of 7 over 28 plus c, or the 28 gets brought as a coefficient and reciprocated to give 1 over 28, and our 4x plus 7 all raised to the 7 plus c. Either one is accepted. In this question, simple integration. The rule for integration is add 1 to the power and divide by that answer. So when I add 1 to the 3, I get 4, I divide by 4. When I add 1 to this 2, I get 3, I divide by 3. And if I integrate 1, I'll simply get x. This is an indefinite integral, so I put plus c at the end. Simplified, my answer is 5 over 4 x to the 4 minus x cubed plus x plus c. In this question, this is a definite integral because we have we have a lower and an upper limit. So the rule is we will integrate the function, and whatever answer we get, we'll first plug the upper limit inside, and then the lower limit in the next bracket, and subtract both answers. So first let's integrate. If I integrate cos x, I will get a positive sin x. And if I integrate sin x, I will get a negative cos x. So the integral of this function will be sin x minus 2 cos x, as you see here. And we want it from 0 to pi over 2. So first we'll plug pi over 2 wherever the x is. That's our upper limit. So we have sin pi over 2 minus 2 cos pi over 2 in our first bracket, minus sign in the middle. And now we're going to plug the lower limit in the second bracket. So we have sin 0 minus 2 cos 0 in this bracket. We will now evaluate. So calculators have to be in radians, and we're going to find the value of sin pi over 2. So sin pi over 2 is a positive 1. So this value will give a positive 1. Find the value of cos pi over 2. Cos pi over 2 is a 0. So that's all. 2 times 0 gives us 0 right here. Minus sign goes back. Then we go to the second bracket. Sign 0 is 0. And then we have cos 0, which is 1. Cos 0 equals 1. So here we have sine 0 is 0. Cos 0 is 1. So it gets multiplied by this to give us a negative 2. From this bracket, we have a 1. Minus sign goes back. And from this bracket, we have a negative 2. So we now have 1 minus negative 2. Two negative sides together makes it a positive, making our answer 1 plus 2, which is 3. In our next question, it's under the topic differential equation. It says, the rate of increase of a population, P, at time t in years is proportional to the population. Now for this part, rate of increase of population, that can be expressed as dp dt. As time passes, the size of the population changes. So change in population over change in time. dp dt, it says, is proportional. So that's our proportional sign to the population p. So all we did is wrote this statement in an expression. Now, to change this proportional sign to an equal, we have to multiply by a constant, and we're calling that constant k. So now we have dp dt equals kp. The rule for differential equation says we have to first separate the variables, then integrate both sides. So we're going to put all the p's on one side and all the t's on the other side. This p is being multiplied, so when it crosses the equal side, it gets divided. So we have 1 over p dp, and this dt goes to the other side and gets multiplied. So now, like I said, we have 1 over p dp equals k dt, and now we can integrate each side. The integral of 1 over p is going to be ln p. And if I integrate k with respect to t, I will get kt plus c. Now the question says we need to show that p satisfied equation pt equals e to the kt plus c. Now here we have ln p equals kt plus c. Thing is, if we raise each of these functions from e, we now have e to the ln p equals e to the kt plus c. The rule is, if we do e to the ln p, we will get p. Anything that's raised from e and ln, we'll get that answer. Meaning, if I do e to the ln 2, I should get 2. So let me show you on our calculator. So we have we have e raised to ln 2, and I tell you that I should get 2 when I press my equal sign. Okay, that's an error. E raised to ln 2 close equals 2. So e to the ln 2 is 2, so e to the ln p will still give me p. So here we have satisfied the equation. P equals e raised to the kt plus c. The second part says that when time is 0, the population is 4,000. So let's calculate the value of c. So we'll plug p to be 4,000. And what I did here was separate these. We know that if we multiplying values, we add the powers. So this can be separated into e to the kt times e to the c, which I did here. Now it says t was 0, so now we have e to the k times 0 times e to the c. Now anything raised to a power of 0 is equal to 1. So this part will give us a 1. So all we have left now is that e raised to the c is equal to 4,000. And for us to find c, we can say c ln e, and we have to do the same thing. We have to ln the other side equals ln 4,000 And when we plug ln 4000 on our calculator, we get 8.29. So the value of C here is 8.29. Now you must be wondering what happened to the ln E. The thing is, ln E is equal to 1. So we have 1 times C, which is just C. Finally, it says, given that K is equal to ln 2, determine the population size when T is equal to 3. So in 3 years after, we want to know what the population is. So we're going back to our equation. P equals e to the kt plus C. It says that K is equal to ln 2, so we now have E equals e to the K, which is ln 2, times T, which is 3, giving us a 3 ln 2, and then our plus C, which we found as 8.29. So what I did was raise from our E ln 2, as a matter of fact, 3 ln 2 plus 8.29, which is 31,870. So we can write that 31,870, and that is the population size at 3 years. Now if this is rounded off, I would get 71. So let's put that to a nearest whole number. 3,000, why I keep saying that? 31,871. Final question says, the diagram includes a parabola f of x equals 30x minus x squared, which models the exterior boundary of a school compound, and the line g of x equals 2x, which models a fence that protects the shaded region as a reserve for agricultural practices. These are superimposed on a Cartesian plane where q is the x-coordinate of the point where the line meets the parabola. So, part A is asking us, part 1 is asking us to find the value of q. Now q, like they say, corresponds to the x-coordinate where the line and the curve meet. So to find that, we will equate g of x to f of x. So we now have 2x equals 30x minus x squared, and we're solving for x. This x squared comes over as a positive, the 30x comes over as a negative, and the 2x remains. So now minus 30x plus 28x plus 2x is a negative 28x. We factor out what's common, which is an x, to be left with x minus 28. So when each factor is equated to 0, we get x equals 0 and x equals 28. Since we already have this value, which is 0, then q has to be 28. In part 2, it says, using integration, determine the area reserved for agricultural activities. Give your answer to the nearest whole number. Now, this is what they want us to find. They want us to find the area of this region. And like they said, we're going to use integration. So it's going to be the integral from 0 to 28 of the functions. Now, thing is, we have this curve and this line. Now the area under this curve is far greater than the area under just the line. So what we will do is subtract the area of the line from the area of the curve. So what we'll do is use those corresponding functions. The function of the curve is 30x minus x squared, and the function of the line is 2x. So that is why we are subtracting the 2x from the 30x minus x squared. So therefore, we have 30x minus x squared minus 2x, and this is what we will integrate. And the integrals are from 0, the limits, sorry, are from 0 to 28 as we discovered. If we integrate 30x, we add 1 to the power to get 2 and divide by 2. For the x squared, we add 1 to the power to get 3 and divide by 3. And if we integrate 2x, we get x squared. So the function that we will be plugging our limits into is 15x squared minus x cubed over 3 minus x squared. First, we will plug the upper limit, which is 28, wherever the x is in our first bracket, and minus the lower limit, which is 0 in our second bracket. Now, 28 squared times 15 is 11,760. 28 cubed over 3 is 7,317.3. And if I square 28, we get 784. Now, when the 0 is plugged into the second bracket, you will get a 0 in either of these positions. So the lower value will give us a 0. When we work this out, we get 3,658.7, and when rounded to the nearest whole number, we get 3,659 square units.